So on this is just a little bit of review from geometry. We got three things to go over. Something called the triangle inequality theorem, which was simply if you're given two sides of a triangle, how short or long does that third side have to be to make a real triangle? So if this third side was like this long, you know that couldn't make a real triangle, right? So, and if it was this long, that couldn't make a real triangle. So there's a certain way to calculate. Oh. Okay. So, what the rule is. How do you know how to make an actual real triangle? This is kind of important for trigonometry because it all deals with triangles, right? So we have the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, for instance, if we have can 5, 10, and 13 be lengths of the sides of a triangle? So we have to check to see if the sum of any two of them is greater than the third. So you pick any two, let's say like 5 and 10, and you're just checking to see is the sum of those greater than the third one, in this case, which is 13. Okay. Now we have to do that for all of them, right? So we have to do a combination of, are those two 10 plus 13? Is that greater than the third one? In this case, 5. And then the last one is 5 and 13. Is that greater than the third one? So there's three combinations, and in each one of these, since all three are true, the answer is yes. And it is a triangle. Now, if we did two of them and they were both yeses and the third one was a no, then it would be false. So it only takes one of them to turn it into a false, and it could not be a triangle. So 2 out of 3 is not good enough, has to be 3 out of 3. Here's a good non-examples, because right away, let's pick the first two. Is 6 plus 9 greater than 15? No. Therefore not a triangle. So if we did the other combinations, like 9 plus 15 is bigger than 6, 6 plus 15 is bigger than 9, but because 6 plus 9 is not bigger than 15, not a triangle. So 2 out of 3 are true, but it has to be 3 out of 3. So small but important detail. Alright, the next part is closely related to that, and that is if you're given two of the sides. So let's say you're not given 3 up here, you're just given 2 of them. What's the possibilities? What's the shortest and the longest it could be? And that's actually quite a simple problem. So the shortest it could be would be something that's the difference. Big minus small, 13 minus 10. That's the smallest it could be, would be 3. And the largest it could be would be the sum, 10 plus 13. Now, it can't actually be 3. It has to be just a little bit bigger than 3. And it can't actually be 23. It has to be a little bit less than 23. So if we want to write something that says, I want all the numbers that's between these two, there's a certain way to do that algebraically. And we do it this way. We put a less than sign, x, and another less than sign. And this right here, this notation, means between. So if you have like 3 is less than x is less than 23, that means all the numbers between 3 and 23. Now notice how it doesn't include 3. So 3 cannot be an answer, but 3.01 can. And same thing here, 23 cannot be an answer. The length could not be 23, but 22.99999 technically could be an answer. Right. Now, why it's written that way, if you just break it down by each inequality, this one says 3 is smaller than all your answers, right? So it means 3 is the lower bound, or the smallest it could be. And if you look at this one, it says all of your answers, x, have to be less than 23. So by saying 3 is smaller than all your answers, and then your answers also have to be less than 23, logically it's the same as saying all your answers are between 3 and 23. So that's why you write it that way. It's just a convenient way to do that. Okay. So go ahead and do number 2. Just give yourself a chance to try that out, see how it goes. Minus 12 is less than x is less than 18 plus 2. 6 and 30. So our answers have to be between 6 and 30 to make a real triangle. So if you're to cut popsicle sticks or straws or whatever, lengths of inches or centimeters, 12 centimeters, 18 centimeters, you can make a triangle with a third side with anything of this length. Okay. Alright, so that's the first part, just kind of going over triangle inequality, just what can physically make a triangle and what cannot. Alright. Next we're just going to do a little review for Pythagorean Theorem. Just to ease into it, let me give you a few numbers. Let's see here. Let's say this is 10, and let's say this is the square root of 19. And go ahead and find x. And it is right triangle, so you are allowed to use Pythagorean Theorem. So x squared plus root 19 squared equals 10 squared. A squared plus b squared equals c squared. You should get something like that. Finish your work, see if you get the same thing. Should I have the plus or minus here? No. Why not? Yeah, we're talking about a length of a side of a triangle. Sides, lengths can't be negative. So, despite taking the square root of both sides here, we only use what's called the principal square root, the positive one. Okay. So, nothing we haven't been doing. It has a radical here, but other than that, same thing from 7th, 8th grade, right? So let's try one with a little more radicals. Let's say this is a right triangle. Let's do 4 and like 2 root 5. 5. And let's find x. So give that a go. See what you get. Again. So a little note about a calculator. If you're going to put this in here, 2 root 5 squared, if you're not quite sure what it is, if I put 2 root 5 and I square it, says it's 10. Now, is that correct? No. So how come it's giving me the wrong answer? Yep. So what do I need to do to fix it? Yeah. So you notice when I wrote it down, I used parentheses. That's not cosmetic. That's actually needed. Right. It's a different problem with and without the parentheses. With the parentheses, it means square everything inside, including the 2. So it's 2 squared times root 5 squared, which is now 4 times 5, which is 20. Without the parentheses, it only squares the root 5, so it thinks it's 2 times 5 only. So just throwing that out there. Calculators, as one of my professors used to say, calculators are really stupid because they do exactly what you tell them to do. They can't read your mind. They can't, know what you really meant, right? So with and without, you get 2 different answers. So with parentheses, 2 root 5. Okay. Just thought point that out on this one. So it's 2 squared, root 5 squared, 4 times 5 is 20. 36. So 6 is x. There we go. Perfect. All right. Now, there's something called Pythagorean triples, which you get 3 positive integers, a, b, and c. So usually, if you just pick 2 random numbers to throw in Pythagorean theorem, the hypotenuse will come out to be a radical, irrational number. There are a few sets that give you an actual c that's not. You get 5. So if you plug in 3 and 4, you get 9 plus 16, which is 25. Root of 25 is 5. Same thing here. If you use 5, 12, you get 25 plus 144, 169. Square root is 13. So that doesn't, you don't get this nice hypotenuse integer very often. But the only thing I want to point out here is that, yes, that's a triangle, but if you have a multiple of it, it also works. So what I mean is this, is that if you have, let's say, 9 and 12, if you can catch on that, well, 9 is 3 times 3. 12 is 4 times 3. So it's really just a multiple of 3 of a 3, 4, 5. So if I have a 9, a 12, I can just multiply that by 3 as well. And I know that that is a right triangle, and that's the correct calculation without having to do the entire Pythagorean theorem. So it's a shortcut if you can recognize it. Now, if you couldn't recognize it, if you just did the whole work, you'd do 144 plus 81, you get 225, take the square root of it, and you'd be 15. So you could still do what we did right here above and do all the work, but it's kind of nice if you recognize it. It will save you a little bit of time, but just throwing it out there. These are the most common, and these ones you don't see too often at all, especially this last one, not too often at all. Okay. So let's say if I just did, let's see, 10 and 26. What could you say this leg equals? $24. Very good. So if you look at this and say, well, 10, that's 5 times 2. The hypotenuse is 26, so I skip over here. That's 13 times 2 is 26. So if I just multiply 12 times 2, I get 24. So you can do a little shortcut there if you spotted it. Okay. So all basic geometry ranging from Pythagorean Theorem, 7th grade, to triangle inequality, which is geometry, high school geometry. All right. Take a breath for a minute, and then we're going to finish up with these last problems here. These two last special right triangles are what's going to give us the coordinates of all the other angles that are not 90 degrees. So you know, like 0 degrees is 1, 0. You know, 90 degrees or pi over 2 is 0, 1. Well, what are the coordinates of the 30 degrees, 45 degrees, 60 degrees? The pi over 6, the pi over 4, and the pi over 3. What are those coordinates? Right? We're going to use, to find the 45 degree pi over 4s, we're going to use a 45, 45, 90 triangle. To find the 30, 60, the pi over 6, and the pi over 3, we're going to use 30, 60, 90. So these are taken directly from geometry. I'm just going to review this, and then we're going to be using this next week to find all those coordinates of everything. Okay. So a little reminder that a 45, 45, 90 is a isosceles triangle. So if you have a 45, 45, 90, if you know one side, let's say it's x, or let me put a number in there. If you know one side, if it's like 3, the other side is automatically that, right? So you might be a little thrown off if you don't know that principle. If I gave you, one side is 3 and told you to find the other two, you might be thinking, well, over here, I know I need 2 sides to put in Pythagorean Theorem to find the third side. You need to have at least 2 sides. But if it's 45, 45, 90, if one of them is 3, the other is 3 as well, automatically. Okay. Now I'm going to do this a long way just one time just to show you what the answer comes out to, but afterwards you can use a shortcut. So let's say we wanted to find the hypotenuse, and we'll use 3 and 3. So I'd do 3 squared plus 3 squared equals x squared. So 9 and 9, which is 18, which is root 18. And if I simplify this, root 18 is the same as root 9 and root 2, right? And root 9 is 3. So root 18 is the same as 3, and then root 2 is just root 2. Now, it's not a coincidence at all that the 2 legs are 3, and the answer came out to 3 root 2. 2 because we have 2 legs. So that's the shortcut for all 45, 45, 90. If you want to find the hypotenuse, all you have to do is take one of the legs, in this case it's 3, and multiply that by root 2. And then you don't have to do the whole Pythagorean theorem. So it's another shortcut that we looked at in geometry. Right? Very, very handy. Now, if I had the leg and I want to get the hypotenuse, then I multiply by root 2. So I just include a root 2. Okay. So from here to here, it turns into 3 root 2. Now, what if I have the hypotenuse and I want to get the leg? If I want to go from hypotenuse to leg, that I'd have to get rid of this root 2 by dividing by root 2. So you do have to kind of pay attention to, well, am I going from leg to hypotenuse or hypotenuse to leg? Of course, if you're going leg to hypotenuse, it's a bigger number, right? So you're including the root 2. If I want to go from hypotenuse to leg, I want my answer to be smaller, so divide by root 2, and it makes the number smaller. Right, so for instance, if I say, if the hypotenuse is 1, and I stipulate that it's a 45, 45, 90, what would be the length of each leg? Okay, if with a hypotenuse of 1. Now, you have to realize, like I said earlier, well, if it's 45, 45, 90, x and y are the same thing. So if you find one, you find the other, it doesn't matter which one you find, it's the same exact problem. But what we do have to know is that if I have the hypotenuse, and I want to get the leg, like right here, if I had 3 root 2, how would I get an answer of just 3? I have to divide by root 2. So that's what I'm going to do. I'm going to take my hypotenuse, I'm just going to divide it by root 2. And I could write it out for both. It's the same exact work. There's nothing different. However, is that an acceptable answer? No, we need to rationalize this. Multiply top and bottom by root 2. So my x and y are root 2 over 2, or half of root 2, if you want to look at it that way. And here's where this all comes together. This is a 45, 45, 90, right? So a 45-degree angle. Pi over 4. So what I just did is I just found the x and y coordinates for pi over 4. It would be root 2 over 2, comma root 2 over 2. Not the prettiest of numbers, but that's just what it comes out to be. So for my unit circle that has a hypotenuse of 1, those are the coordinates. Okay. Another way of saying that, since we recognize it's 45, 45, 90, or in our case, pi over 4, right? I can now ask, well, what's the cosine of pi over 4? Or 45 degrees. Cosine, again, is x coordinate. It's equal to root 2 over 2. So that's where we're heading next week. Not today, but just so you know, well, why are we stopping and doing this review geometries? Because it's all used to help you find your sine and cosines of all the angles, not just the 90 degree increments, but all of them. Okay. All right. Now, we did the 45s, but what about those 30 and 60 degree angles as well? So then we have a different triangle with some different rules there. So if we're here, let's say we start with, I'll just do 1, I think. Yeah. Let's say we start with 1. In order to go from it's all based on the short leg. So if you have the short leg, you're good to go. If you have the short leg and you want to find the hypotenuse, all you got to do is double the short leg. So that's 2. So this is 1, that's 2. Just double it. And if I want to find the longer leg, I go back to my short leg and I just multiply that by root 3. So that's going to be whatever this is times root 3. Nothing more. Now you have to know it's a 30, 60, 90. It has to have that in the diagram or the directions in order to use this shortcut. Same thing with the last one. You can't just add and divide or multiply divide by root 2 on any triangle that looks like it. It has to be in the directions that it is a 45, 45, 90 or 36, 90 to use these shortcuts. All right. So small but important detail. So I'll do just one more example on the side here. So let's say this was like 8. And notice I gave the hypotenuse, right? I could find the other 2 if I knew ahead of time it was a 30, 60, 90. Right? I know the hypotenuse is twice as big as the shorter leg. So if this is 8, that must be 4. And I know the long leg is just this short leg times root 3. So if this is 4, that's 4 root 3. Keep in mind that this long leg should be bigger than the short leg, but smaller than the hypotenuse. Hypotenuse is always the longest one. So if you ever mix these up or doing it wrong, just keep in mind, if you find the decimal for both of these, the hypotenuse should be the bigger number. And if not, then you got them flipped. Right? So always just go back to the basic definitions just to make sure if you need to. Alright, so let's do just one practice and we'll get ourselves started. Let's say short is 5. And just find x and y. Yeah, keep it that way. Give that a try. See what you get. How's that look? X is 5 root 2 and y is 10? Yes? Oh, what? Is it 5 root 3 or 5 root 2?
5 root
3. So there's a common mistake sometimes, and people they mix up the root 2 from a 45-45 and the root 3 from a 30-60-90. So the way to keep that straight in your head is that a 30-60-90 is a root 3. So the 3 goes with the 3 in the problem, the triangle, goes with the 3 in the root. And I've heard the other way as well. Some people say, oh, the 2 means there's 2 45s. So that's when you use the root 2 is when you have 2 45s. So that way you don't accidentally have root 2s popping up in 30-60-90s and root 3s popping up in 45-90s. So these are the small things after teaching for 20 years that, once everything else is, figured out, it's those tiny little things that make a big difference of just not mixing up. Okay? All right, so I'm going to pass out your assignment, and you got plenty of time to work on that.